Testing? Hello? Can you guys hear me? All right, good. Everybody get some coffee? All awake now? I feel like I'm just starting to come alive now. All right, so today we're going to talk about integrating Node.js into your ecosystem. My name is Alex Liu, and I'm currently an engineer on the Netflix website team. And we're in the middle of migrating our website over to Node.js. And so it's been a really, really exciting journey for us so far. And today I just kind of want to share some of those experiences with everybody. And specifically around the piece of how we integrated Node into our ecosystem. Does this sound okay? I feel like I'm dropping in and out a little bit. Okay. But first, I'm going to start off with a story about our friend Oz. So Oz is a pretty cool guy. He's the kind of guy you want to hang out with. And he gets to build really cool stuff. So today Oz wants to build a new app. His organization uses Java, so as long as he's using that, it's pretty smooth sailing for him. And like at most large orgs, platform pieces are typically abstracted in a way that makes it pretty easy to plug and play to get the stuff that you want, right? So if you don't have functionality A, that's fine, just drop it in a jar, you're good to go, right? Don't have secret sauce B, no problem, drop it in. Don't have superjar C, just keep on dropping jars in. And this, I'm just using Java example here, but really you could replace this with any language of your choosing. And so it all works out really great, and because he's walking the paved path, and things are just beautiful. But then Oz finds out about this thing called Node.js. He knows it's a cool new JS framework thingamajig, and he totally wants to build his next app in Node. So he builds a prototype, and he's in love. He's totally enamored with this thing. It's absolutely the perfect stack for his teams to be building UIs on. But he wants to get an even better read on this, right? He wants to take this prototype, put it into prod, have it take some traffic, and really what he's after is to find out whether or not this is a feasible solution for him. So he heads on over to chat with the platform and ops teams, and they say, beware, you travel the road less traveled. It will not be an easy journey, but we'll help you as best as we can. And Oz, he's kind of an optimistic guy, so he says, I'm going to go ahead and move forward anyway. And he thinks to himself, I'll figure out the problems and I'll deal with them when I get there. So unfortunately, all the platform pieces he needs to work on in prod don't actually exist yet. So he could take this one-time cost of rebuilding these as node modules, but Oz is not part of the platform team. And he really doesn't want to get in the business of owning these in the long term. It's unfortunately just a commitment that he doesn't have the resources for. So very quickly, he finds himself in a bit of a bad place with not enough support and not enough resources. And unfortunately, this is exactly the kind of thing that anyone at a large org might run into, no matter what new technology it is that you're wanting to try. And so taking a step back, I think it's really important to answer this question first. What is your goal? And this might seem like a really, really silly question, but I think oftentimes we get caught up in sort of the how without having really clearly thought out the what or the why. And usually what you want is to try new technology. Really, you want to see if it meets your specific needs. And I know we're all here because we love Node and we're interested in Node, but don't do it just because it worked for company X, right? Definitely try it out for yourself and see if it works for you. The catch, though, is that you rarely have the opportunity to actually start completely from scratch. Whether you own an internal app used by employees across your company or you have a customer-facing app that's serving millions of customers, you really need to have a migration plan in place. So if you're not rebuilding your entire app at once, then you need to have a plan that enables you to move incrementally. Like with any migration, you need to be able to do this in digestible chunks. And of course, if it wasn't already assumed, by choosing to take this path, you are acknowledging that you are moving off the paved road. Whether that blessed language is Java, .NET, Python, whatever language of you're choosing, you're basically making the conscious choice that you'll be facing tough challenges later down the road. And you want to have answers for those challenges, especially as you start your journey. And so in answering these challenges, we need to be able to identify and address any potential issues as early as possible. And so to do this, I introduced to you the 6-step plan for integrating Node.js. And you can think of this as a recipe for success that we use at Netflix. As we go through this, I just want to say that I'm giving this sort of presentation in the context of that we're moving our UI, our UI web server over to Node.js. But even so, I think a lot of the lessons that we learned here are totally applicable for other use cases as well. So step one, identify your ecosystem. Let's begin with a question. What does your ecosystem look like? And the answer to this question might be more important than you think, because the right answer will enable you to start moving immediately. So one of the most common answers is a monolithic application. Wikipedia, the bastion of reliable information here, defines it as a single-tiered software application in which the user interface and data access code are combined into a single program from a single platform. And I've highlighted the portions here which I think are key in defining what that looks like. And so anybody who's been in software development long enough has probably worked on one of these. And if you haven't, geez, you are totally missing out. So here's what your typical monolithic app might look like. Looks pretty similar to one of the slides I think that Ryan Stevens had in his presentation just earlier. And it's got pretty much everything you need in a self-contained box. So you've got your data access, your business logic, and finally the UI on top. But this too here is also a monolithic app. So it might be slightly more modular because we've now replaced the data access layer with jars. And maybe these jars are owned by other teams, or maybe they're owned by a platform. But ultimately, the good thing is that you've at least moved that part out of your app and moved the data into somewhere else. So it's not hosting your app anymore. And how that data might be retrieved is perhaps slightly more magical now, but that's okay, right? Because your app is now slightly leaner because of it. By contrast, your ecosystem might be more along the lines of SOA, service-oriented architecture. And again, we consult Wikipedia here. A design pattern based on distinct pieces of software providing application functionality as services to other applications via a protocol. And you might try to argue that the monolithic app that we just looked at is kind of SOA, but there's a slight difference here. The definition here says that we must talk to other applications via a protocol. So there's no mention of a language here, right? So to actually fit this description, we need to evolve this app just a little bit more. So we've now jettisoned the jars, and we asked for data via a protocol. And it's subtle, right? Because the difference here is that the layer in which we ask for that data is no longer tied to Java. And in the early days, this protocol might have been SOAP or RPC, but these days more likely to be JSON via REST. And this is ideally the place you want to be, right? Resting all the things gives you the ability to support a much more diverse ecosystem. Because that means you can start with something like this, and as you ship functionality over, end up something that looks like this. You guys like that, huh? All right, so now that we've got this kind of environment set up, how do we manage traffic between our existing stack and our new stack? So that leads us into our next step, which is to use configurable routing to help you move incrementally. So you could actually use something like a reverse proxy, and I bet most of you are already using something like this. But what we want is not just a vanilla proxy, right? We actually want something that's a little bit more dynamic, a little bit more configurable. And ideally, this routing should be as configurable as you need it to be. And when I say configurable, what that means is that you should be able to slice the routing in a couple different ways. So the most obvious use case would be to divert traffic based on URLs. Alternatively, you could also slice the traffic using an A/B test. You could also divert perhaps just a percentage of your traffic to the new stack, like say 10%. And then, of course, as you gather more data and reach stability on this new stack, continue to turn that knob all the way to 100%. Another option, you could do this via geolocation. The use case might be that perhaps in a specific geo, you're getting a lower amount of traffic, and you could effectively use that entire geo as an A/B test of your new stack. And of course, it's always really helpful to have a kill switch. So if things do go terribly wrong, you can, at a moment's notice, back to your existing stack. And you want to avoid the temptation of using a subdomain here. It may seem like a really easy way to do routing, but you want this migration to be as transparent as possible to your end users. And spinning up new subdomains may also have some potentially unintended SEO impacts. So now that we have a plan for moving incrementally, let's talk about the things that you'll need to get into a production-ready state. We want to make sure it's actually all things necessary and not just things that are needed to get a prototype up and running. And so in all likelihood, these are problems that have already been solved in your org. The first being service discovery. So whether you're in the cloud or using some sort of vanilla load balancing, there's likely going to be a need for your app to integrate with some common service discovery system. So your app needs to do a couple things here. It needs to register itself as being available, needs a way to continually tell other services that it's still healthy and able to take traffic. And lastly, you also need a way to be able to discover dependent services. And it's a good question to ask whether or not that last one is an issue for a use case, because it can be quite common to simply send all dependent traffic to external load balancer of some sort. But sometimes you might need to discover mid-tier services that aren't behind one. And so you can think of this as basically a client-side discovery piece that can figure out which instances of a particular service you want to be talking to. And in the end, it really does depend on how far you want to take this optimization. But ultimately, being able to do some of these, like the client-side discovery piece, means you can save your app a couple hops and reduce overall latency. You also want to make sure you have a story around configuration. This is an obvious one, but sometimes the implementation can be very specific to your infrastructure. You want to determine where your configurations should be stored. It might be that your org has some kind of centralized configuration system, in which case then you'll want to find a story about how to store and fetch configs from that store. But it might also be that you just have a local config file that gets deployed with your build. You might also want to consider dynamic configuration. That is configuration that can change at runtime. And so you might think, what would the use case be for that? And you can totally leverage them to do the things that we just talked about. So things like diverting traffic based on a percentage or having that kill switch can be enabled by having dynamic configuration. I also can't stress how important metrics are as a part of the launch of a new stack. Observability of your app is of the utmost importance. And I'll say it again just to overemphasize this point. You must have a way to be able to infer the state of your app based on a set of observable data. That means if your plan is to A/B test this new stack, you need to ensure that you're on a level playing field with your existing stack. So you need to have insight into all the things that might be useful when trying to debug potential prod issues. And ideally, these metrics are being reported in real time so that you can always have a good handle on monitoring the health and state of your app. And it's better to err on the side of being too chatty than not chatty enough, because I can't even begin to count the number of times where someone on our team said, hey, we should totally add a metric for that, for when we ran into a situation where we just did not have enough data to go on. And having real-time metrics does mean you can also set up some sensible prod alerts. And lastly, I just want to note the difference actually between logging something and reporting a metric for it. Because you can report metrics for something that causes a 500. So every time I throw a 500, I'll report a metric, right? But that doesn't actually give you the insight that's needed to debug why you return a 500. And so I think it's great to always be verbose and log all relevant context when you're running into things that are unexpected. Building and deployment can also be something that's often overlooked, and you want to make sure that you have it covered as part of your initial exploration. There's nothing worse than having a prototype that worked great in dev and test, but then finding out that you have no way of actually getting it out to prod. At Netflix, we're built out on AWS, and so AMIs are our minimum unit of deployment. So that means to spin up a new stack, we have to bake a new image with all the stuff that we need. Depending on your deployment model, you might have to do something similar, basically setting up a VM with Node and all the things that it needs. And as you invest in this piece, make sure that you have a really good story around continuous integration and deployment as well, because likely your org will already have an existing pipeline for this kind of thing for most projects, and whether that's Jenkins or something else. But if you want to be able to move quickly in this new stack, it needs to be working on at least the same level of efficiency as your existing stack. So that was a lot of stuff, but typically these are all the necessary pieces that you'll want to have in place before getting your prototype out to prod. So now we kind of have a good idea of what that gap looks like, right? But what are our options for moving forward? You've really only got two, rebuild or reuse. And we know that we need all, if not most of these pieces, but which of these can you reuse and which do you want to rebuild? It's a really good question, and there's no one-size-fits-all answer. And as we talk about the choices that we'll make, I want to be clear that as with any migration, you are playing for the long game. So that means the cost of doing these integration bits should ideally be reduced to 0 over a longer period of time. And it's really difficult to avoid incurring this cost up front, but in the long term, you don't want to be spending too much time maintaining these platform pieces. So let's look at rebuild. I think this is where most of us would likely look first, and in some cases, it's actually not a bad choice. It's possible that some of these existing pieces, right, were implemented in perhaps a non-optimal way, or maybe they're in a poor state of maintenance, right? So that means moving to a new stack actually presents an opportunity to reevaluate. And maybe you'll want to do a refactor and rebuild that specific piece in your node layer. Rebuilding pieces as a lightweight facade can actually be really helpful in your prototyping stage as well. So you can think of it as a rebuild, but without full feature parity. So during the prototyping stage, you really just want to get the ball rolling to see if something works, and this gives you a lot of flexibility to decide later on what you want to do. Do be careful though, because if you take the route of rebuilding too many pieces, then you could end up in a place where you're actually spending too much time building existing platform pieces as opposed to your actual app. And depending on how large and comprehensive that ecosystem is, it could be even a larger undertaking than just your app. And I think that's a really legitimate concern, because in some cases you'll inevitably run into this sort of chicken and egg problem where, you know, platform is like, we're not going to build a JS client for you because there's no demand for it, but then, you know, if there's no JS client, then perhaps node adoption might be inhibited in some way. And so it's just a difficult problem. So your second option is to reuse existing pieces. And in an ideal world, this is actually the default choice, right? Your goal should be to avoid rebuilding all the things that already exist. And ultimately, that saves you time, effort, and reduces overall potential maintenance over the long term. And a great example of this is if we had committed to building a core platform module. So let's say, like, as an example, something super, super simple, like a REST client that just makes HTTP calls. So we're going all out. We're maintaining feature parity with the platform version. So we've got timeouts, retries, exponential backoff, you know, caching maybe, and a ton of other things. And let's say today or later down the road, platform revs to a new major version, right? They introduce major new functionality or they deprecate some functionality. Are you now going to have to update your custom implementation? Do you have the time and resources to do this? Or is it possible that platform might be willing to sort of adopt and take ownership of the client you've written? I mean, these are all really, really tough questions. And by simply reusing pieces that already exist, we've kind of avoided this whole situation. From another perspective, it might also be that reusing existing pieces is another lifeline for your migration strategy. You know, you can reuse pieces now to get you off the ground and running, but at a later point in time, you could choose to rebuild those pieces as native modules to Node. Reusing also allowed us to stay focused on our goals. Rebuilding the platform, at least for us, was really not in the core domain of the UI team. And so instead, reusing pieces really allowed us to focus on the app and ultimately the user experience. So now that we have a better idea of the pros and cons of each, we looked at our ecosystem and we said, all right, how many of these pieces already exist and are supported at the platform level? And luckily for us, Netflix is designed very much around the concept of being a platform as a service, albeit a Java-based platform as a service. So most of these pieces existed already. But it's not JavaScript, right? So we spent all this time talking about all these different things, and we basically got no further than Oz did. So recall earlier that I said that if you've got an existing platform piece to reuse it, which is great and makes a lot of sense if your new stack is this written in the same language as your old stack. But then it wouldn't really be a new stack, right? So it turns out these are not the implementations we are looking for, which is kind of unfortunate. But not all is lost. We can actually leverage these existing pieces using a sidecar. So what's a sidecar, you ask? Great question. So let's skip Wikipedia this time. This is my definition here. A process which runs on an instance along with your application, housing all the things necessary for it to integrate seamlessly within an existing ecosystem. We can visualize it like this. So we've got our box here with Node on it, and then we also have a Java process running on that same box. And this Java process is actually the process that's running all the integration bits that we care about. So that's what we call the sidecar. So you'll note the little wheel icon there. I know. So some of you probably just died a little inside, right? We mixed our Java and we mixed our Node. You know, believe me, we had the same exact thought when this idea first crossed our minds. I mean, in what world could this possibly be a good idea? You know, we've got the Java guy angry, we've got the Node guys angry. It's just, yeah. But hold on, there's a good reason for all of this. So we've got this Java sidecar process, and you can think of it as being like conceptually attached to our main process. So it complements Node very well by providing all the platform features that would be otherwise unavailable to us. So all those jars and libs that you couldn't use before, now you can. It becomes really trivial then for Node to make requests to your Java process, which will then do some magic, you know, via platform jars to talk to external services. And it's a really simple concept, but in practice it becomes really powerful because you're now able to basically build all your new stuff in Node and continue to leverage all the existing services through a sidecar. And it's a great solution because this can be flexible in a lot of different ways, right? You can put Nginx in front still. You can still spin up multiple processes if you want to. The only difference now is that you know, all service requests are handled by the sidecar. So in this situation, this particular situation here, the sidecar is simply a proxy or translator for those service requests. Now you could choose to have that sidecar do more for you, you know, like read or write to local databases, that kind of thing. But I would caution you to tread really lightly in that situation, because if Node is to be your way forward, you actually don't want to put too much new stuff into your sidecar, right? Because you could very easily fall into the trap of then having to maintain two separate stacks. So my recommendation is actually to avoid putting anything new in the sidecar. And if anything, you should treat it as a migration tool, right? So over the long term, you could potentially start to carve pieces out of the sidecar and move it back into Node. So if you recall our rebuild and reuse dilemma for a moment, this is how we ended up splitting up our choices. So as you can see, we chose to reuse as much as we could, you know, and especially things like, I guess, like builds and deployment, right? Like we got that practically for free because it was already set up. But with the sidecar, we were able to actually take advantage of all these existing pieces. And so ultimately that reduced the amount of complexity and surface area that we needed to cover to get our prototype out to prod. And I think the biggest win for us here was really the service discovery piece, because it's needed to for other services to discover Node as well as for Node to discover other services. And it's a huge piece of our ecosystem that's constantly evolving, you know, given the fact that we are pretty much completely cloud-based. And it means we didn't want to get in the business of owning what's essentially, you know, something core to the platform. And you might have noticed here that I've split metrics into two parts. So we've got a metrics collection on the rebuild side and the reporting side on the reuse side. This will make more sense in just a moment, so just hang on to that thought. And even though I do say we rebuilt these pieces, our rebuilds were actually very, very light. That is, you can sort of think of it as a wrapper-like module that does not maintain full feature parity. And in fact, it's a lot like the suggestion I made earlier that you do for prototyping. So let's look at an example. Imagine a configuration service. So from Node's perspective, it's just a simple HTTP call. Makes a call to your sidecar, get something back. We built a pretty lightweight wrapper module that just makes REST calls. And the Java process actually has the fully featured platform jar. And depending on the environment and conditions, the sidecar might choose to make a request for dynamic value over the wire. And since the sidecar has these jars, it's the one that's actually doing pretty much all of the heavy lifting for us. So that includes all the important bits like fault tolerance and resiliency. So things like retries, timeouts, exponential backups, circuit breakers, caching, and in some cases, even fallbacks. But to Node, we just continue to make REST calls. And so these are things that would have taken us a long time to rebuild in the Node layer just to even reach parity with the platform versions. And so using a sidecar really let us sort of take time to build only user-facing features as opposed to rebuilding existing platform pieces. And the nice thing about this too is that we can treat the sidecar a lot like a black box. Node still has that lightweight client that we just saw, but for all intents and purposes, the sidecar isn't there for us. All right, so if we pretend the sidecar isn't there, we can first treat it like a black box. Now, if say one day platform decides that we've seen enough Node adoption, we want to build a fully featured JS client, then we can actually evolve our system a little bit more, and it's all going to be fairly seamless. So we can start by removing the sidecar, and then dropping in the fully featured client. So that's pretty awesome, right? This idea is really, really powerful because it kind of gives us the choice to decide when and how we want to make that transition. And in my opinion, it's a total game changer for enabling incremental migration. So remember how we split our metrics into two components? We totally leveraged the sidecar to do that same thing using the same concept. So we basically rebuilt just the collection component in the Node layer, and then because we really needed to control that inside the Node process. But ultimately the reporting stuff, which is handled by the jar, let's just go ahead and reuse that. It's already there, no need to rebuild it. Now there are some gotchas with this kind of setup. Because you are now running another process on the same box, you are introducing some element of risk. So that means you'll have to watch your resources, especially with sidecar processes that tend to be more resource intensive. And since you'll be talking usually over HTTP with your sidecar, you also want to make sure that things like timeouts, retries, or connection pools are all set up correctly on both sides of those processes. Now we talked a little bit about metrics earlier. And we really want to have those in place because when things do go wrong, which they inevitably will, you'll need to be able to diagnose where in that request path things went wrong. So looking at this example, let's say you have some inbound requests and your outbound requests to your external services start dropping somewhere along the line, right? Do you know if it's between your proxy and Node, or do you know if it's between Node and your sidecar? Or is it the sidecar that's dropping the requests? Right? And even when you do have really good metrics for all of these things, you still might run into situations where you're just going to really have to put on your detective hat and just start digging through. Unfortunately, this is just additional complexity that is the trade-off of being able to reuse these platform pieces. Which leads us to our next top tip, get metrics in place. They are a total lifesaver. So if this sidecar as a concept interests you in any way, feel free to check out our tech blog post on our Java sidecar. We actually just open sourced this last month. So personally, I think it makes a lot of sense because it totally removes identical language as a necessary requirement for building a really rich ecosystem of services. So ultimately, what this does is enable UI teams to really focus on our core domain, which is building great user experiences. And just in case you guys don't know, prana, I believe, is the Sanskrit word for life force. You might have heard of it before if you've done yoga or martial arts. Think of it as an energy that connects all things in the universe. So in this respect, prana lets our Node app come alive in our ecosystem, so we think it's a very fitting name. As a result of introducing the sidecar, we've actually seen some really encouraging diversity as well within the company. The sidecar concept itself actually started off as something that was specific to our Node app, but the platform team liked the idea so much that they decided to adopt it, and we're now using it across the company. So after all is said and done, if you think the sidecar thing is still a little bit crazy, well, it worked for Batman and Robin, so if that doesn't sell you, then I don't know what will. And last up, Node it up. So equipped with all this great knowledge, you're ready to sort of hit the road and start your journey. You can tell your naysayers, don't worry, man, I got it covered. And that's all I got. Thanks.
Thank you, Alex. So what questions do we have? The microphone's walking on one over right over there.
Hi. Hi, I'm Samir from PayPal. Just wanted to check how you're leveraging Docker. I saw that in one of the slides.
Yeah, so I put that in there, but we are not leveraging it right now. I had meant to speak to that point, but it's something we are experimenting with, but nothing solid yet.
Hi, sorry, Alan from Intuit. I wanted to clarify, when you talk about using the sidecar, how are you communicating from the Node.js app to the sidecar, and how seamless is the change from using the sidecar to using the downstream sort of systems directly?
Well, so we talk with our sidecar over REST, so it's going to be all HTTP. Like I talked about, the idea is kind of that most of the complex logic around doing environment detection and all the stuff that's you do serialization or deserialization for specific services are handled by the jars in the sidecar. And so for us, some of those services are going to be HTTP based from the jar side. Some of them are not. We've tried to, it helps that our ecosystem is pretty much like most of the things are REST based. So if we really wanted to, you could build them in Node. But like I talked about, right, like there's a big trade-off there. And so ultimately, the idea is that this is sort of a really nice in-between that gets us up and running really quickly. And if Node does reach sort of critical mass, then having a fully featured client that comes in at a later point should just be a drop-in and go.
Hi, Prabhasna from Financial Engines. Are there any security issues using Node.js?
Security issues? Not sure I'm qualified to answer that, but I don't know. Anything? Yeah. Yeah, I mean, I don't think it's any different than like the concerns are no different than they would be in any other stack. So there's nothing specific to Node that would make it any more or, less cumbersome or worrisome.
Hello. Do you have any memory leak issue, and how do you handle the memory leak issue? Memory leak problem?
Yeah, we have had a couple, and I think we've had a couple different strategies for trying to find those and deal with them. The introduction of the flame graphs and profiling in Linux has been really helpful for us, and so we've been able to do profiling and then looking to see basically exactly how much time is being spent doing what, and we can see that over a specific period of time for specific instances. And generally, that's how we've tracked down these memory leaks. Sorry?
I mean, what kind of reason that is causing the memory leak?
What kind of things cause memory leaks?
Yes.
Lots. Typically, user error. We've seen that a lot, and it's just a function of getting used to the way that Node does things. And even though we are a UI team and everybody works on JavaScript and we know it, there are some differences, right, between working in a browser and working in Node. And a lot of it is just education, right? Teaching people like how to do things and how not to do things.
How does session management work seamlessly between the Node.js and the sidecar, or do you rely on the sidecar kind of as a legacy platform to handle all the session enforcement?
Yeah, our node layer is completely stateless, so we don't do any sort of session management. Everything, you can think of Node as being like a really lightweight templating layer that really just serves UIs. So all of the stuff that's like, user state or user data is going to be handled by external services.
I'm Bhavin from Financial Engines. What kind of caching mechanism you use?
Caching?
Yeah.
We don't really do any caching on the node layer either. We expect most of that to be handled fairly seamlessly for us by the external services. And like I mentioned in the talk, like some of those jars will have that capability built in. And so where possible, we try to leverage that.
Hi, Akbar. A quick question, with the sidecar, how come you guys decided to do it on the same host? Like is it basically so your servers are all fully federated? And versus say, since you are connecting to it over a REST API, I mean, obviously the other option would be to actually create a separate sidecar layer.
Right. So that choice for us was really because we needed service discovery, and we didn't want to rebuild that piece, and we have, an existing platform jar that does all that service discovery for us, and that was like the quickest and most efficient way for us to really get our node into the cloud.
We got one right up front here.
So when
the microphone's on its way.
When you switch from kind of an all Java stack to kind of separating out Node, one of the things that happens is your UI layer, which you build, becomes really fast, and then that puts pressure on the backend layer to get faster. So how do you deal with kind of talking through the teams and trying to get them to speed up? Like, how does that work at Netflix? Like, how do you force them to not slow you down?
So I don't know if force would be the right word, but I think it's just sort of an organic kind of thing, right? Like as you sort of split separation of concerns into different layers, and that means each of these layers can become that much more specific to just the thing that you're doing, right? So basically you end up having these services that do just one thing, but they do it really blazingly fast. And as we saw, like this is sort of an exercise in like decoupling that monolithic app, right? So you're separating all these concerns into different layers, and there's no reason that external services that you depend on shouldn't be built in the same way. And if we're talking about like creating a rich ecosystem of services, and each one is doing just like one thing, but doing that thing really quickly, then that enables you to sort of like compose these different services together in a way that's much easier to manage than having this like giant app that like has one entry point and does a bajillion things.
I have two questions. One is how do you handle multi-core? How do you utilize multiple CPU? And the second question is how much percentage of CPU for a typical process? Yeah.
So for the first question, we actually right now are not scaling, or we're not launching multiple processes on our boxes because we do have that sidecar process, and that introduces some risk, right? So our boxes are not running just Node. And so for us, it's actually been helpful to sort of keep that a one-to-one ratio. So we've got a box with one Java sidecar process and one Node process, and then just scale it up that way, as opposed to scaling multiple Node processes. And then, sorry, what was your second question? Oh, was it CPU usage, right? I mean, that's just really going to depend, right? If it's at idle, it's not doing anything. Like at load, like if you have a lot of traffic, then you want to use as much CPU as you possibly can without it falling over, right?
1 second.
Your Nginx reverse proxy, are you also using that to serve your static asset, or is it your Node.js the one that's serving the static asset?
Yeah, so we had Nginx in front to serve some static assets for some time, but we've actually tried to move most of that out of the app now. And we actually do serve our assets out of Node because Node serves as the origin for our CDN. And I actually did give another talk earlier this year about our packaging system, which is all built out in Node as well. So if you're interested, like, I can totally send you a link to those slides.
Any other questions? All right, thank you very much, Alex.
Thanks, guys.